Hello everyone, my name is Darren and my group members are Shreya and Espen. Today, we'll be presenting our SC1015 mini project on students' life and satisfaction. These are the contents we'll be going through today. Let's begin by addressing a universal truth among university students: stress. Stress is a word that resonates deeply among university students. It affects students worldwide, impacting academic performance, mental health, and overall well-being. To help cope with the stress, students tend to rely on their support system and social circle, ultimately leading to higher levels of student satisfaction. Student satisfaction also includes other aspects such as the quality of education, campus facilities, and the sense of belonging within the university community. By understanding and addressing these factors, we can significantly enhance the student's experience. Our objective is to leverage on machine learning to help reduce stress levels, increase satisfaction, and present ways to improve student life. To do this, we'll be using a dataset provided by Kaggle, consisting of student responses for the survey about ideal student life and key factors that are important in student life. I'll now hand over the time to Shreya to share more about EDA.
Thank you, Darren. So now we take a look at exploratory data analysis to better understand our dataset. Before analyzing our dataset, we first clean our data by dropping columns that do not help in predicting our problem statement. On doing this, we are left with 15 columns. We then check each data field for null or ambiguous values and then remove it. We now have 2,940 data points in our clean dataset, and we go on to perform univariate statistics on it as seen on the slide. To better understand our data, we analyzed columns by creating count plots. On plotting career field, which specifies the level of education a student is acquiring, we found the majority of students are undergrads. Next, we created a count plot based on citizenship and found that most were citizens. We also found that most students were female. Similarly, we created count plots for housing type, level of stress, and satisfaction with student life. We found that most students lived out of campus and reported stress levels of around 2 to 3 on a scale of 0 to 9 on average. Since we found the majority of the students were undergraduates from the count plot, we found the exact number of undergraduate students, which happens to be 2,683, and only considered them in our analysis for factors affecting stress levels. We then used bivariate data analysis to determine different factors that affect stress levels using Violin plot and a box plot. Now year of study ranges from 1 to 5, and the Violin plot reports stress levels of around 3 to 4 for all years of study on average. We then found from the box plot that students enrolled in a school of foreign college tend to have maximum stress levels on an average. Next, Esmond will share about machine learning to explore factors affecting stress and overall quality of student life in more detail.
Thank you, Shreya. Moving on to the machine learning portion of our project. Before we start, we need to figure out what type of machine learning we'll be using. There are various types such as regression, classification, and clustering. So first, we need to determine the nature of the questions we are looking into. In our case, we have two questions which both are on finding the factors contributing to stress level and student life satisfaction respectively. We can build a machine learning model to help us predict the various states of stress level and satisfaction level. Hence, this will be a prediction of a discrete class label. And as the number of target variables for both questions are more than 2, they are multi-class classification problem. So, how does machine learning actually solve our objectives? By building a good model, we'll be able to predict target variables, and from there, we'll be able to identify factors which have significant effect on the model, and this allows us to better focus on those relevant factors to help improve the situation. For example, if it was found that housing type is an important factor to the model for satisfaction level, we can explore more on it, such as how it may boost or reduce student life satisfaction to help students build a more enjoyable student life. Now that we know what type of machine learning we'll be using and how it is going to solve our problem, it is time to pick the specific models to use. Our team chose Decision Tree Classifier and Random Forest Classifier. These two models were exposed to us during curriculum, so it is natural for us to adopt it first. Decision Tree is also a simple model which is good to use as a starting model, and Random Forest is an advanced version of Decision Tree where it combines multiple decision trees to improve performance, making it more accurate than Decision Tree. Moving on to the preparation of the dataset. First, we will drop irrelevant columns which we think have no impact on the model, and rows with missing values using the drop NA function. Next, we will convert the relevant columns to categorical for further processing. Then, we applied one hot encoding to those columns. This is because some machine learning models are unable to work with categorical data. Therefore, to fix this issue, we have to convert those data into numerical data. And one hot encoding is one of the techniques to do so, and it is better than a normal integer encoding as it prevents misinterpretation and biasness, which normal integer encoding might cause. Lastly, we convert our target variables stress level into low, medium, high, and student satisfaction level into dissatisfied, neutral, and satisfied. Afterwards, we create two sets of datasets, one for stress level prediction and the other one for student life satisfaction prediction. And keep in mind we have to drop the necessary columns. We then proceed to choose 80-20 as our train test ratio and set a random state. This is the fitting of the two models. We have to import the models from sklearn and fit the model accordingly. After generating the confusion matrix and the classification report for both models, we can clearly observe that random forest is likely to have high accuracy, precision, recall, and F1 score when compared to the decision tree. This indicates that the random forest classifier model was able to better classify the target variable, making it the better model for the two given problem. Next, we went on to explore other models which we can use apart from the two, and we found three models that are rather popular. First is the logistic regression. However, we are unable to use it as it is used for binary classification tasks, while in our case, it's multi-class classification tasks. Next, support vector classification, also known as SVC, is a powerful model that is effective in processing high-dimensional data. Lastly, the k-nearest neighbor, also known as KNN, is a simple and effective model which is widely used in machine learning. This is the fitting of SVC and KNN. We have to first import the relevant models from sklearn and fit the model accordingly. Moving on, after obtaining the confusion matrix and classification report for SVC and KNN, we compared them to the random forest. We found that SVC have high accuracy score compared to random forest, which may look great at first glance. However, on further inspection, we noticed that the precision score for SVC is especially low, which may indicate that it is not a good model. Precision is how precise the model is predicting for predicted positives, and in our case, we might want to prioritize precision as by knowing precisely why students have high stress or why students are satisfied with student life, we can better help students. And as for KNN, it performs similarly to random forest in terms of all the metrics. Here's a short summary of the machine learning portion. When choosing the right model for a problem, it is important to keep the following considerations in mind: the type of problem, the data you're working with, compare performance metrics carefully, consider the context of the problem, and lastly, don't limit yourself to just one kind of model. Experiment with multiple models. And with that, I'll pass the time back to Darren to wrap up the presentation.
Thank you, Esmond. I'll now summarize the outcome of our project. Our aim was to leverage on machine learning to reduce stress levels and increase student satisfaction. Although we did not directly achieve this, we have successfully identified the top 5 factors affecting stress levels and student satisfaction through the use of feature importance. However, our model doesn't explain how it exactly affects it. Through this project, we are also able to note an interesting observation, that is stress and satisfaction are closely linked. However, it's unclear if the relationship is positive or negative, leaving room for further investigation and future research. As for our recommendations based on the data insights, we can observe that the number of events students volunteer in is a top factor influencing both stress and satisfaction. Hence, we would like to suggest universities to provide opportunities to cater to a broader range of students, allowing them to engage in events they are passionate about. In conclusion, our SC1015 mini project sheds light on the profound impact of stress among university students worldwide. While our project did not directly reduce student stress level or increase student satisfaction, we were able to identify the top 5 factors respectively. With this insight, it will set the path for future exploration and intervention strategies aimed at tackling these issues. You have come to the end of our presentation. Goodbye!